Okay, this is term 2, week 7, chemistry CA. Okay, we'll run through it, we'll fly through it. Hydrocarbons are organic compounds. Which of the following are only present in hydrocarbons? Obviously, hydrocarbon, so hydrogen, carbon only. Okay, in the exam, how did it come? Which of the following are organic compounds? By the way, the first question came in exam when they asked which of the following are hydrocarbons, huh? As I predicted in the exam, in the quiz video. Uh, Organic compounds, it's any carbon hydrogen containing compound. Any carbon containing compound except the oxides. Okay, so any oxide, carbon dioxide, or any carbonate. Okay, or hydrogen carbonates. Any HCO3, any CO3, any CO or CO2. We don't like those. Which of the following are alkanes? Okay, we're gonna start with our families. We're gonna go one by one. Okay, so I'm gonna label family. I'm gonna label general formula. Okay, I'm gonna label instead of general formula, خلاص general formula, we're gonna let's go family and general formula, and then we'll go in more in detail. Alkanes are, we know this. Okay, CnH2n plus 2. Okay, so for example, if n was 1, it will be C1, which is a C, H4. Okay, that will be the first alkane. How do you name alkanes? There's a table. Okay, you have methane, or the prefixes. Okay, it's always the prefixes and then the suffixes. Okay, the suffix is the family. So for alkanes, the suffix, it will always end with ane. Okay, so for example, when n equals 1, okay, it's meth. When it's 2, it's eth. Okay, when it's 3, it's prop. When 4, it's but. Okay, when it's 5, it's pent. When it's 6, it's hex. When it's 7, it's hept. When it's 8, it's oct. When it's 9, is I think non. Okay. When it's 10, it's dik. Okay. One way I memorized it is from the TikTok song methane, ethan, propan, butan, pentan, hexan, heptan, octan, nonan, dikan. Okay, I'm serious, wallah. This is I remember it from there. Okay, so you can use whatever you want. Also, monkeys eat peanut butter, putting honey, holding on nice ducks. That's apparently something our teacher made. Anyways, you can memorize that, whatever you want, but these need to be memorized. Okay. Which of the following are alkanes? So which ones obey the formula CnH2n plus 2? Let's take a look. C6H6, obviously not. They have the same number. CH4. Carbon is 1. So if you input 1 carbon, so it's going to be CH. 2 times 1 is what? 2. 2n plus 2. 2n plus 2. 2 times 1 is 2, and then plus 2 is 4. So should really look like this. Is it? Yes. This is methane. Okay. C3H8. Let's take a look. Substitute 3. CnH2n plus 2. Okay, substitute 3. You're going to get C3H. 2 times 3 is 6. Plus 2 is 8. Is that correct? Yes. C5H12. Let's substitute 5 now. 2 times 5 is 10. Plus 2 is 12. So C5H12. Correct. Okay. So this is actually propane. This is pentane. And this is wrong. This is an alkene. Alkene, not alkane. We're gonna get to that later. Okay, why? Because if you substitute 2 into CnH2n plus 1, you're gonna get C2H6. Okay, so that will be wrong. Okay, how are alkenes produced? Okay, alkenes can be produced by the combustion reaction of alkanes. No. Okay, alkenes can be produced by the dehydration reaction of alcohols. I'm gonna open the notes because I want to go through the notes and explain. Okay, you know what? Instead of going through the notes here, I'm gonna use the notes I have in my copybook because I think they're a bit more organized and more straightforward than these. Okay, so I'll open the notes and show you my notes. Yeah, so before I carry on with the quiz, I'm just gonna go through my own notes. Over here I have organic chemistry. Moving on to alkane. Okay, so I'm first gonna go over the families and then I'll explain each family on its own. Okay, we have up until point 3. So 1 second. Yeah, so we have a lot for me to explain actually. Let me chop and start. Okay, so the first family is alkanes and its general formula is CnH2n plus 2. The second family is alkenes. Okay, and we're gonna call them CnH2n. Okay. The third family is alkanol. Okay, I'm gonna help you memorize these in a second. Alkanol is CnH2n plus 1 OH. Okay. Alkanoic acid is the fourth family. I don't think we have alkanoic acid. Alkanoic acid. No, we do not. There's alkanols. Okay, I'll go up until alkanol. Okay, we leave alkanoic acid for next week. Okay, so there is, other than the general formula, there's something you need to know called the functional group. Okay, the functional group is what gives the molecule its function. If it has a functional group, that means it can react. If it doesn't have a functional group, of course it cannot react, right? Okay, alkanes don't have a functional group, so no functional group. Okay, none. Okay, so for that reason, as you can predict, if it doesn't have a functional group, then the molecule itself doesn't have much function. Okay, so it has very low reactivity. Alkenes have a functional group called the carbon double bond, and alkanols have the functional group OH, which is called the hydroxyl group. Okay, hydroxyl group. Okay, so whenever you see a carbon double bond, that's going to be alkene. Whenever you see OH, that's going to be alkanol. You want an easy way to memorize? Alkenes are CnH2n. Okay, why CnH2n? Because now you have a carbon double bond. When you double bond carbon, that means it can hold one less bond. So here it can hold one less hydrogen, and here it's going to hold one less hydrogen. So one less, so it's two less. So two less from alkanes, that means it's just CnH2n. Okay, and then alkanol, we replaced our final H, we removed one and we put an OH. Okay, so that's how it works. Type. Let me move on to saturated and unsaturated. Okay, saturated and unsaturated. If there's a carbon double bond, okay, if there's a carbon double bond, C, then it's gonna be unsaturated. Okay, this must be memorized. So for that reason, alkenes are unsaturated, but alkanes are saturated. Okay, so I'll put on and I'll put dot. Okay, unsaturated. Type. Let me start with that. You don't need to know that. You don't need to know that. Let me start with alkanes. Okay, we'll start one by one, and I want to. Actually, no, I won't. Let me continue. Let me start. I think because we have to name. There's a few questions with naming. Recognize, identify hydrocarbon. Okay, no. I'll jump straight to the reactions. Okay, of alkanes and alkenes. Okay, the reactions of alkanes. Alkanes over here. I'm recording, right? Alkanes have three reactions that they can undergo. The first being combustion. Okay, it's flammable, so it will combust. Okay, so it's gonna flame. The third being cracking. Okay, and the fourth being chlorination. Okay, let's start with combustion. Combustion is pretty straightforward. There's properties you need to memorize, which I'm gonna open the notes for. Let me just go to combustion. Okay, so you have two types of combustions. You have complete combustion and you have incomplete combustion. What do you need to know? The first thing you need to know is that a complete combustion occurs when you have a sufficient amount of oxygen. When there's oxygen, it will burn. You guys know for combustion to occur, you need oxygen. Okay, so for a complete combustion, there's a sufficient amount of oxygen. Okay, so the reaction where there's a sufficient amount of oxygen, that is complete. Also for complete combustion, you need to know that it happens for those that have low percentage of carbon. Okay, there's not much carbon. You need to know that. Okay, it also produces carbon dioxide. They both produce carbon dioxide and water. Okay, they both produce carbon dioxide and water, complete and incomplete. You need to know that for complete combustion, more energy is released. Okay, you need to know more energy is released. You need to know that for complete combustion, a clean blue flame is used. Okay, a clean blue flame will be produced. So as you can see here, okay, it's a clean blue flame. However, for an incomplete combustion, it so happens when there's an insufficient amount of oxygen. You need to know this. You need to know that it happens for molecules that have a lot of carbon. You see, there's two carbon here. It produces, like this is not going to ask you about that, but The main key point is insufficient or sufficient. Okay, that's the main point. Okay, you need to know that for an incomplete combustion, it doesn't produce carbon dioxide, it produces carbon monoxide. Okay, and water as usual. Okay, they both produce water, but the difference for complete is combusts completely to give carbon dioxide, but for incomplete, it's carbon monoxide. Okay, you need to know that for incomplete combustion, it's wasteful and uneconomic. Okay, so it wastes. Okay, and you need to know that the flame is a yellow, smoky, sooty flame, or if you want to say orangey, sooty flame. Okay, yellow color. That is combustion. That was very quick, very easy, nothing too hard. The second equation is cracking. Okay, cracking is when you break down. It's the breaking, or I think they put it in the notes, so let me not. Cracking, yeah. Cracking, from the word cracking, it's the process of breaking something, right? What are you breaking? Alkanes are very long, and when they're long, they're not useful at all, so they don't react. So for that reason, we break it down to shorter alkanes, and what do they produce with it? Alkenes. One example, I'll give you an example. Let's say you have a C, 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 C. Okay, a huge carbon chain, and they all have hydrogens and whatever connected to them. Okay, 1, 2, 3, 4, 5, 6. Okay, they're all connected to hydrogens. I don't care. My point is, this isn't useful. For what we do, we break it down, we get another alkane. Okay, but you're left with now this here. Okay, so what do we do with this? This is actually, sorry, this over here. Ignore the one outside. This is a leftover alkene. Okay, so that means cracking actually also produces, not only does it produce a short chain alkane, the byproduct would be an alkene. Okay, you need to know this. And sometimes it produces hydrogen gas. You need to know that as well. Okay, but my point is, cracking, you crack a big alkane to produce an alkane plus an alkene. Yeah, so that's what cracking is. And it is also deemed, since you're producing an alkene, this is actually a method of preparing alkenes. Okay? Type. We're done here, cracking done. You need to know there are conditions for cracking. These must be memorized, okay? 10 to 12 atmosphere and 500 degrees Celsius. And since it's a long chain alkane that's useless and you can't use it and whatever, and it's unreactable, you're probably wondering, how do you react it to break it down? That's perfect. To do the reaction, you need to give it some energy. And in chemistry, how do we make reactions that require a lot of energy happen quickly? We give them a catalyst. And in this case, the catalysts are Al2O3 and SiO2 together, so aluminum oxide and silicon dioxide, or chromium oxide. Okay, these must be memorized. Okay, ما في يعني جدال فيه. Okay, temperature 10 to 12 atm, 500 degrees Celsius, chromium oxide, or Al2O3 plus SiO2. Okay, I forgot to mention one thing for incomplete combustion, is that one bad thing about incomplete combustion, other than the wasteful and uneconomic, it contributes to pollution, as it produces carbon monoxide, because carbon monoxide is pollutant and it's toxic, and it actually binds to the hemoglobin in your body. So instead of carrying oxygen, they carry carbon monoxide. Okay, so it's gonna make your brain cells deprived of oxygen. Anyways, so that's the second reaction. The next one is chlorination. So this is actually how cracking is set up in the lab. Make sure you take a look at this. You could get it in the exam. Okay, ceramic coal. So cracking over here. What's she doing here? Yeah, so they put the catalyst here, and they need to be heated. Okay, obviously, why do they need to be heated? 500 degrees Celsius, because it's a slow reaction. You need to give it some energy. Okay, so in all cracking reactions, it will produce a shorter alkane and an alkene and maybe hydrogen. Okay, you will notice this. Okay, okay, you may use unglazed pottery. Okay, pottery can be used as a catalyst as well. Okay, pottery is like the dalla. Some people call it a dalla or something. So this is the first setup. They put the catalyst, and the gas is gonna go here. The hydrogen gas is gonna go out. So you're gonna put the methane, whatever, you're gonna put it in here, and it's gonna react and break into the product. Okay, so your products are actually most of them are they're all gonna be gases, okay? So for that reason, they go up here. And then how can these be separated? Obviously by fractional distillation. When you have more than one gas with close boiling points, you separate them with fractional distillation after you get them here. Okay, chlorination is the last one. It's called a substitution reaction. Okay, substitution reaction meaning you substitute. Okay, so I'm gonna kind of اختصر. Okay, chlorination is when you replace. Okay, I'll do it fast. It's the replacement of replacing one or more atoms with chlorine. Okay, very easy. So this chlorination can only take place. Also, this applies for bromination. Okay, so just in case it comes in the exam, and I saw it in the quiz, that's why. Bromination, so Br. Okay, so it works with Cl and Br. The first thing is I'm going to draw for you an ethene molecule, or was it, sorry, methane molecule. Where did I get ethene? I don't know. Methane, okay? I'm going to add to it chlorine, bonded to chlorine, okay? This reaction can only take place, you need to know, it can only take place in sunlight, because the catalyst is actually the UV rays of the sun. Okay, so when you add these in the presence of ultraviolet rays, okay, it's a photochemical reaction because it can only take place in front of photo means yani sunlight. Okay, what's this UV gonna do? It's gonna come here to the chlorine, it's gonna distribute it. Okay, it's now gonna make this chlorine free, and it's gonna be called what we call a free radical. Okay, this free radical is all over the place and it likes to bond. Okay, so it comes here and it kicks the hydrogen out. It kicks it out and it comes and takes its place. Okay, so it comes, it goes here, takes the hydrogen out. Whoa. Comes here, wait, comes here, kicks the, stop! Comes here, okay, comes here, kicks the, خلاص الله يسامحك والله. Whoa. Kicks the hydrogen out, takes the chlorine over here, and go. Why does it only select a little bit of stuff? Okay, goes, and the chlorine's here now. Okay, where you're going to be asking, Walid, where does the hydrogen go? It's a substitution reaction. Like how you substitute players in a football team, this one goes back here. Okay, so what are you going to be left with now? C, H, 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 but now you have Cl. Okay, plus now you have HCl. Okay. That's pretty much it. What do you call this product? It's actually called, it was called methane, right? But now since you added chlorine, we call it chloromethane. Okay, let's say you had 2 of these Cls, then you're going to do 2 substitutions and you're going to get, instead of CH3Cl, you're going to get 2 Cls now, and it's going to be called dichloromethane. Okay, this same rule goes for bromine. Instead of ClCl, they put BrBr. It would also work. Okay, so I'm gonna keep on doing this. Let's say now she put 3, it would do the same thing. The product would be CH, but now 3 Cls. Okay, it's gonna be called trichloromethane. Okay, and the 4th time, let's say she put 4, it's gonna be CCl, Cl, Cl, and so it would be called tetrachloromethane. Okay, these are all things my teacher mentioned here. Tetrachloromethane or carbon tetrachloride. Okay, it's gonna make way more sense when you see the questions. Okay, it can only occur in see, it will not occur in the dark. It can only occur in sunlight. Okay, next we have alkenes. Alkenes, now I'll go through it a bit quicker than alkanes. Okay, alkenes have the general formula CnH2n, right? I'm not going to draw it, and you guys know that they have the functional group, which is carbon double bond, right? Type carbon double bond, you need to know that this characterizes it as what unsaturated, right? Type I'm not going to draw all of them, but when we get to isomers in the quiz, I'm going to explain what an isomer is. But for now, let me continue explaining what alkenes are. Okay. we can prepare alkenes three ways, okay? Preparation of alkenes. How do you prepare alkenes? We know that alkenes, we can do it the first way by cracking, okay? That's the first thing, okay? So cracking. Okay, so preparing alkenes. The first one we said is through cracking, right? Why? Because remember we said when you crack a big alkane, you get a smaller alkane plus an alkene. Okay. What were the conditions for it? Remember Al2O3 at 500 degrees Celsius from 10 to 12 atm, plus SiO2 at 500 degrees Celsius 10 to 12 atm, or Cr2O3 at 500 degrees Celsius at 10 to 12 atm. Okay, and you need to know these conditions. Okay. The other one, this is industrially, Industrially, they use cracking because it's more efficient. In the lab, what do? We call it dehydration of alcohol. Okay? Dehydration of alcohol. What's alcohol? Okay? First, before going to alcohol, dehydration you need to know is removing water. Okay? If you know, alcohols are CnH2n plus 1. If you remove water, you're removing two H's, one OH. Alcohols are CnH2n plus 1 OH. If you're dehydrating it, that means you're removing one oxygen and you're removing two H's. So you're removing this one and you can remove this plus 1. So now you're left with CnH2n. Isn't that what alkenes are? CnH2n, right? So that way you just got an alkene from an alcohol. So let me explain this process. The dehydration of alcohol, the conditions of it now, you need to be at 180 degrees Celsius and you need to add hot H2SO4. Okay? This is how to prepare alkenes. So either dehydration of alcohols or cracking alkanes. Now the reactions of alkenes. What do alkenes do? How do they react? The first one, as usual, is combustion. And we went over the incomplete and complete combustions. Okay? The second one is what we call addition reactions. Okay? Addition reactions, they only have one product. But substitution, like we did for chlorination and bromination, they have two products. So addition, you're just adding two things to make one bigger thing. Okay? So the first addition reaction is what we're going to call hydrogenation. And as you guessed it, it's the adding of hydrogen. Okay? So let's say you have this alkene over here, characterized by the carbon double bond. Don't forget, okay, this is C2H4 over here. Let's say you're adding a hydrogen molecule to it. Okay, what are the conditions of hydrogenation? Obviously, no reaction can occur without a catalyst. So the catalyst here is nickel at 200 degrees Celsius. Okay, what do you get when you add hydrogen? When you add C2H4, you add two hydrogens to it, it's going to be plus 2. And that's C2H6. And isn't that an alkane? Isn't that ethane? Yes, right? So when you're adding two hydrogens, that looks like alkane. Okay, so you're going to get this molecule. You're going to tell me, Walid, what happened to the carbon double bond? Exactly. This is why this reaction needs energy, because you need energy to split this bond and this bond. Okay, so when this bond is split, the carbon double bond, the carbon now has room to bond two more things. This one has one more space for one more, and this one has space for one more, so it can bond two more things. That's why these two hydrogens go here. Okay. Whew. Too much talking. Too much. Okay. The last one is hydration. Over here we have hydration, and then we have polymerization. Oh my god, ما بيخلص already. Okay, hydration. Okay, the second addition reaction is what we call hydration. When you're hydrated or dehydrated, obviously that means you're adding water, you're working with water. So we're adding H2O. Okay, what are the conditions? As we said earlier, H2SO4 over here. You need H2SO4 at 180 degrees Celsius. But here they said 80 degrees, is that correct? Yes, hydrogenation and hydration. Yeah, so here they said 80. Dehydration can occur. Where is it? Dehydration can occur at 180 degrees Celsius, but hydration can occur at 80 degrees Celsius. So I'm just gonna use here. So hydration is the next reaction. You're adding what? Water. Okay, you're adding H2O. Okay, so when you add H2O to an alkene, okay, C2H4, you're adding H2O, it's gonna come C2H, it's gonna come C2H, H5OH. You're gonna tell me, طب why isn't it C2H6OH? طب okay, انت have you ever seen this? We don't do this, right? Sorry, why isn't it C2H6O? Okay, because if you add these, you're gonna get C2H6O. No, you can't have the O alone. So what do? We make it look like an alcohol. So we make this 5, and we take one H over here. Okay. But they write it like this. Why do they write it like this? Because this is drawn like this: carbon, carbon, H, H, H. Okay, you have over here H, over here you have OH, and here you have H. Okay, that's how it's drawn. So it's C with 3 hydrogens, then C with 2 hydrogens, then OH. That's why they write it like this. This is what we call the structural formula, by the way. Okay. Anyways, so hydration is the addition of water. What are the conditions? H2SO4 at 80 degrees Celsius, or H3PO4, okay, at 300 degrees Celsius and 70 atmosphere. Okay, you need to know these conditions. Okay. Okay. The third one is bromination, which is the same as chlorination, so I'm gonna kind of skip it. Yeah, I'm gonna skip bromination. Okay, but you need to know 2 things. Bromination, you can use bromine dissolved in water, or you can use bromine over here. Saturated orange mix. Okay, yeah. This isn't. I don't like how they explained it here. I'm gonna explain it my way here. Okay, so we're working with alkenes. So as usual, we're gonna draw our alkenes. Okay, don't forget alkene have the carbon double bond. Okay, so our alkene plus Br. Okay, what's gonna happen? Like I told you, bromination, chlorination. Bromination is a substitution reaction like chlorination. So what's gonna happen? This breaks. So this Br will go here, and the other one will go to the H. So it's gonna be like this: CBr, H, over here H. Wait, what? CH. Yeah. Sorry. Bromination here is it's addition, right? Yeah, addition. The only time it's substitution is when you're working with alkanes. But when you're working with alkenes, it's just addition. Okay? But the carbon double bond still breaks. Even if it's addition, the carbon double bond still has to break. So you're gonna still have the H, Br, now Br. Okay? As easy as that. Okay? The conditions, you have to be in CCl4, okay, at RTP. Okay? That's it. So you need to be dissolved in CCl4. So this reaction also is used to differentiate between saturated and unsaturated hydrocarbons. Why? Okay, unsaturated hydrocarbons, in other words, what are unsaturated hydrocarbons? Are alkenes, right? But saturated hydrocarbons are what? Alkanes. Which ones don't have a carbon double bond? Alkanes, because no carbon double bond means it's saturated. How do you differentiate between them? Because when you react alkenes with bromine, okay, it decolorizes in the dark. But alkanes, like we said, for chlorination, because I told you, for alkanes, chlorination and bromination undergo the same process, okay? Like I said, you need light for it, okay? It only takes place in sunlight. So chlorination and bromination of alkanes will only take place in the sunlight, UV rays, okay? But for alkenes, not necessarily. Okay, you're gonna tell me, Walid, can I use chlorine now? Can I do chlorination of alkenes? Of course you can. عادي. Okay, but like I told you, it's gonna follow the same rules that alkenes follow for addition reactions. Okay, the last one is polymerization. Okay, I'm not gonna talk too much about this, but basically, how can I say this? Wait. Let's say I come and put for you 4 CH2. Okay, that means 4 of CH2 molecules, 4 of the alkene, 4 of the alkene ethene. Okay, If you have so many molecules, they actually line up and make what we call a polymer. A polymer is one huge chain molecule, one big one, okay? So therefore it's gonna look like this. 4CH2CH2 goes and lines up like this, okay? Comes like this. You see how they just all line up, okay? We have 4 of this, so you're gonna have 1, 2, 3, and over here will be our 4th one, okay? Okay, like this. طيب, so this is what polymerization, that's all you need to know, okay? It's just alkane molecules tend to add each other, forming very large molecules, okay? Such reactions are called polymerization. So when you have so many alkenes, they just line up and make one big one. That's not that hard. Okay. خلاص, I think we have alcohols. Alcohols, I'm gonna fly through them, okay? It's not that hard, because really it's not that hard. Alcohols now, I'm taking 30 minutes just explaining. Wow. Okay, alcohols, okay? CN, H2N plus 1, OH. That's the general formula. What's the functional group? The functional group are OH, okay? Type. And other people call this hydroxyl, okay? It's also called hydroxyl. Type. What do you need to know? You need to know the reactions, okay, as usual. Naming, I hope she doesn't get naming for you tomorrow. I don't think naming is required, because naming has its own, like, I think it should be one exam only about naming. That's how long naming is. Okay. Naming, to prepare alcohols, okay? To prepare alcohols, and then we'll go for the reactions. The first one is fermentation, and this only for those who do bioidine alcoholic fermentation, okay? Yeasts undergo alcoholic fermentation, which is anaerobic respiration, when there's no oxygen for them to do aerobic respiration and get energy, okay? So fermentation occurs in the absence of oxygen. What happens? You have a glucose molecule, okay, in the presence of yeasts at room temperature, because if it's not at room temperature, the yeast will die. Whoever doesn't know what yeasts are small microorganisms. They're basically like animals, okay, that do these reactions, okay? They're very, very tiny. So C6H12O6 is broken into methane C2H5OH, okay? So show methane as the ethanol, and I keep mixing up with the names. It's broken down to ethanol. Okay, why is it ethanol? By the way, because it has 2 carbons, so it follows eth, and we're working with alcohol, so it's going to be ethanol. Okay, so C2H5OH and carbon dioxide gas. Okay, you need to know this reaction. Fermentation is a breakdown of glucose in the absence of oxygen. Okay, type. Very, very easy. You need to know that this reaction is actually what we call self-limiting. What does self-limiting mean? It means it stops its own. When does it stop? It stops when the sugar runs out, obviously, or when the yeast dies. Why would the yeast die? Man, there's alcohol, and alcohol, kills cells. It might kill the yeast. Type. Another way is hydration. Hydration of ethene, okay, or alkenes. Like we talked about hydration earlier, okay, which was adding H2O. As you saw earlier, when you add H2O to an alkene, you're gonna get HOH. Like it's gonna follow the same general formula for alcohols. Let me show you an example. Okay, we know hydration is the adding of water. Okay, so these are kind of like us repeating ourselves. You're gonna get now C2 instead of H6. What do? We can't let the oxygen stand alone. We're gonna give the oxygen 1 hydrogen, and as you can see, this is the hydroxyl group, and this is actually an alcohol. Okay, what are the conditions for this? H3PO4, phosphoric acid at 300 degrees Celsius, 60 to 70 atm. Okay, oxidation of alcohol. Can be part A. Okay, I'll go over this quickly, but I'll open the notes for it. Okay. So this is the conditions, whatever. Fermentation, self-limiting, hydration of ethene, whatever. These are the uses of ethanol. Okay, make sure you know them. Okay, go over them. Hatta this stuff, go over them. Hydration of. These are 2 ways, by the way. fermentation and hydration of ethene are both ways to produce an alcohol. Okay, but this is industrial because it's easier. Okay, it's faster, produces more yield. Okay, so obviously we do this industrially, and this is more pure. By the way, for fermentation, the alcohol produced is not pure. Okay, so to purify it, they undergo fractional distillation. Okay, it's over here. You can read over this if you want. Okay. Okay, reactions. The first one is combustion. Okay, alcohols always go through combustion. All our organic compounds that we're taking, they all undergo combustion. Okay, since it undergoes combustion, as you can see, are easy, simple combustion reaction. It's just burning in the presence of oxygen to give carbon dioxide and water. Okay, you need to know that ethanol burns with a clean flame. The reason for that, all alcohols burn with a clean flame. The reason for that is that it has a low carbon percentage. I told you, low carbon percentages have complete combustions, and complete combustions take place at light, clean flames. Okay, so for that reason, all alcohols, they undergo clean combustion and have a clean flame. Okay. The second one is oxidation of alcohols. This is a bit straightforward. All you need to know is that oxidation of alcohols in the presence of oxygen gets you carboxylic acid and water. Okay, but this oxygen doesn't mean you're adding oxygen O. No, it's called an oxidizing agent. And you have two options for oxidizing agents. The first one is KMNO4. How do you know that this reaction occurred? Is when it changes from purple to colorless. Okay, and then you have potassium dichromate. How do you know this reaction occurred, oxidation? Because when you have an acid, the potassium dichromate changes from orange to green. Okay, so alcohol being oxidized gets you carboxylic acid plus water. So it gets you an acid. Carboxylic acid is for next week. We'll go over that later. Esterification, our last one. Acids plus alcohol gets you ester and water. You need a catalyst. Okay, the catalyst in this case is H2SO4 for esters. Again, I don't feel she's gonna answer this. I'm talking too much. Let me chop and yalla. Identify alkanes from a list. We said this is easy. Question 4: how are alkenes produced? Can they be produced by combustion of alkanes? No. Combustion of alkanes gets you carbon dioxide and water. Can be produced by the dehydration of alcohols? Yes. When you take water out of an alcohol, you get CnH2n, so that's an alkene. Alkenes can be produced by cracking of alkanes, like we said, of course, yes. Alkenes can be produced by the substitution reaction of alkanes. No, substitution does nothing but just change the structure a bit. Okay, so it doesn't change the family. Which of the following is true about ethanol? Okay, ethanol is an alcohol, type of alcohol. Okay, we know ethanol can be produced by fermentation, and we also know ethanol can be produced by hydration. So it's two ways to produce ethanol. We just did them right now. Okay, fermentation and hydration. Okay, of an alkene, hydration of an alkene. Can ethanol be produced by combustion of ethane? No, combustion is not used to produce anything. Okay, ethanol can be produced by addition of halogens to ethene. No, why? Which of the following represents a complete combustion of C2H6? Complete. What does complete mean? Complete means carbon dioxide is produced, and all of them is carbon dioxide is produced. So to do it, you just need to balance it. You guys know for combustion, you're burning in the presence of oxygen. Okay, you're producing carbon dioxide and water. So you're gonna have to balance this. Start with balancing the carbons. You have 2 here, so put a 2 here. Okay, you now have 4 here and 5 here. You have 3 hydrogens here, so you need to put a 3 here. 6 hydrogens here, so you need to put 3 here. So now you have 9 here, and you have 4 here. 9, as you have 3 plus 4, 7. Okay, so you need to continue balancing. Okay, you have 7 here. Okay, 4 from here, oxygens, 2 times 2, 4 oxygens here, then 3 here, so you have 7. So what do you do here to make this 7? We multiply by 7 over 2. Remember, when it has a 2 as a subscript, you just multiply 7 divided by the subscript. Now, since now we don't have any with fractions, we want to get rid of this 2, so we multiply by 2 to everything. So it's going to be 2C2H6 plus 7O2 to produce 4CO2 plus 6H2O. Okay, question 7. Which of the following equation represents the production of ethanol from ethene? Ethanol from ethene. Ethene, you want to get an all. If you want to remember it, write down the general formula. Okay, CnH2n is ethene, or like it's an alkene. Then you want to get ethanol, which is CnH2n plus 1 OH. What did I add? 1 hydrogen, 2 hydrogens actually, and 1 oxygen, which is called water, right? So we're adding water. Okay, and all of these are all adding water. What do we know? You just need to balance it. Ethanol from ethane. You're producing ethanol. Ethanol, eth is the subscript, is a suffix for 2, right? Ethanol. So substitute 2 as your n, so you can get C2H5, because 2 times 2 is 4 plus 1, 5 OH. Okay, you're producing this, and ethene, it's CnH2n, right? So C2H4. So you're starting with C2H4 and you're ending with C2H5OH. Okay, this is the only one that's correct. These are all wrong. I don't know why they would be correct. Okay, you need to know that ethene is a gas, but ethanol, okay, the alcohols are all either liquids or aqueous. Okay, so aqueous would be correct, but liquids also is correct, okay, if you see it. You need to know that since this reaction takes place, what are the conditions for this? Obviously, hydration. It's 300 degrees Celsius, H3PO4, and 60 to 70 atm. H3PO4 is phosphoric acid. Since it's occurring at 300 degrees Celsius, is it possible for the water to be a liquid at this temperature? Obviously not. Okay, that's what we need to remember. What's the general formula of alkanes? CnH2n plus 2. Having 2 carbons, ethane, it will be substitute 2, C2H2 times 2 plus 2 is 6. Okay. Question 9, formula of alkenes. How many questions is this? 22, oh my god. Formula of alkenes, it's CnH2n, having 2 carbons, again, C2H4. Question 10, what is the general molecular formula for alkanols? CnH2n plus 1OH. Select the structure that belongs to alkanols. What do we know about alkanols? It has an OH functional group. OH functional group. No, come back. OH functional group. So which one here has OH? This one. Okay, and I mentioned this while explaining. You can tell Walid, why is this? Or why isn't it this? This is actually carboxylic acid. Okay, you can tell me, Walid, what's a carboxylic? Whatever. What did you just say? This over here, this C double bond OOH. This is called a COOH group. Okay, and this is called the carboxyl group, and that's for next week. Okay, so you need to know it's a single bonded OH without any oxygen double bond. We are not supposed to see any oxygen double bond. Okay, never. Okay, it's not for what we have this week. Consider the following compounds. What does compound 1 and 2 have in common? This is now isomers. Okay, let's take a look. Is it the same structural format? Do these look the same? Obviously not. Is it the same physical properties? No two molecules have the same physical properties. Okay, 2 different molecules. They can't have the same exact physical properties. Is it the same chemical properties? Again, you can't have the same chemical properties. You can have similar chemical properties. Let's take a look. Can be same molecular formula. 1, 2, 3, 4. So C4. You have A10, H10. Let's take a look here. 1, 2, 3, 4. So C4. And if you count the hydrogens, it's also going to be H10. What's different? It's the same molecular formula, but different what? Structural formulas. So that's what we call an isomer. An isomer is when you have the same molecular formula, however, you have different structural formulas. Okay, I hope that's pretty clear. Question 12. Ethene reacts with hydrogen in the presence of finely divided nickel at 200 degrees Celsius as follows. Okay, so this is what we call adding a hydrogen, right? So what we call hydrogenation. It's pretty simple. You think an exam she's going to ask you what it's called? Is it hydrogenation? No, right? Obviously not. She's either going to ask you this. She's going to ask you hydrogenation, but she's either going to ask you which one is hydrogenation. You're going to have to click on this, or she's going to ask you what are the conditions. So you'll say nickel at 200 degrees Celsius. Question 13. Consider the compounds CH4, C2H6, and C3H8. You need to know they have the same general molecular formula. They undergo substitution reactions. They have similar methods of preparation. What are these compounds called? Homologous series. Many people got it wrong last week. Okay, I'm going to show you the answers, all the possible answers, in case she decides to change it, because actually the question got cancelled, by the way, and she's adding it as a bonus question because it was wrong. I told my teacher. But over here, members of the same homologous series. You need to know same general formula. This is obvious. Similar chemical properties. Why was it wrong? Because our lovely regional said same chemical properties in the answer, but that's wrong. It can't possibly be same, because last year they all clicked same and they all got it wrong. For the teachers, and she started apparently apparently the Miss Nada, the chemistry regional, got really pissed at the chem teachers, and she was like, how can you teach your students that it's the same chemical properties, you don't know chemistry, whatever, I don't know, whatever, la 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 la. She got mad, but she was like, make sure you teach your students it's similar, there's no way you're teaching your students wrong chemistry, what's wrong with you? Okay, anyway, she crashed out, okay? That's why she put it as similar, and my teacher stressed on similar. If you say same, you get it wrong. That's why she's mad, because last week in RCA, same was the correct answer. They sent a lovely message to Miss Nada saying, that's how'd you put it as same when last year you yelled at us and whatever. Anyway, have the same functional group. Okay, obviously homologous series, if they're from the same family, then it's the same functional group. You need to know that they differ from the one before and the one after by a CH2 unit. Okay, يعني C, like مثلا methane and ethane, they're both from the alkane family, so CH4 and C2H6. What's different? You added one carbon and two hydrogens. So what's different is just a CH2 unit. Okay. Show a trend in physical properties. So it has a trend in physical properties. So not the same physical properties, but it has similar physical properties. Okay. Or not even similar. Just say they have a trend in physical properties. Okay, trend in physical properties. They also have similar methods of preparation. Okay, they undergo substitution reactions. Okay, these two, since they're in the quiz, you need to know them. Question 14, something is an example of hydrocarbon, obviously C6H6. Question 15, saturated. Which one's saturated if it doesn't have a carbon double bond? Okay, so let's take a look. They didn't give us any formulas. C2H4. C2H4 is an alkene. You need to take a look. Is it alkene or alkane? How do you know if it's alkene or alkane? Alkane is CH2N plus 2. Alkene is C2H2, H2N. Okay, check. If it's an alkane, then what? It's gonna be saturated because there's no carbon double bond. So let's see. The first one, obviously, this is double of that. So this is an alkene. So this is gonna be unsaturated, right? C3H. This is gonna come because it's a great question. Huh? Please make sure you know this. C3H8. The hydrogen is not double the carbon, so it's gonna be an alkane. So it's gonna be saturated. C5H12. The hydrogens is not double, so it's gonna be an alkane. So also it's gonna be saturated. And here the hydrogens is double, so it's gonna be unsaturated. Right? Very easy. Question 16. Upon adding component X, the reddish brown color of bromine water is rapidly discharged. Okay, what is compound X? What do we know does bromination and decolorizes it quickly? If you say rapidly discharged, you should know it's alkene. Alkanes and alkenes both react with bromine, but the difference is alkenes have a quick reaction. Okay? Therefore, it's going to be an alkene, and the only alkene from the options was C2H4. Okay, because it follows. How do you know if it's an alkene? It follows the formula CnH2n. Okay, so hydrogen must be double of carbon. Question 17. Oh, this is a long recording. Pentane has the following structural formula. Select the structural isomers for pentane. Okay, a structural isomer is that has a branch. Okay. You're gonna tell me طب وليد كيف. If you take a look at these, they all have the same formula. You want to try it yourself, you can try, but you're gonna get C5H12 after counting all of them. What's different? Here, this is one branch. Okay? An isomer differs in structural form. You're gonna tell me طب وليد this is different structural form. You see how it's bent? No. It's only considered a different structural formula when you have a branch. And how do you know it's a branch? If you cannot complete it with one stroke of your pen. So this one you complete with one stroke. But here, you're going to need two strokes. You see how I needed two strokes to make that plus? Here, you can do it with one stroke. Okay, easy peasy. Here, you need two strokes. شايف? The ones that need two strokes have a different structural formula and therefore are structural isomers. Chlorine Cl2 is added to methane CH4. The reaction between methane and chlorine can be speeded up by what? Remember, alkane with chlorination, we said you need UV light, okay? What's it called? It's called substitution because chlorine takes the place of the hydrogen, right? Select the possible products of the reaction between methane and chlorine, okay? I told you, methane and chlorine, you're gonna get one of the CH4, like one of the carbons bonded to chlorines. Why is this wrong? Because you got rid of the carbon. How do you get rid of carbon? Why is this wrong? It's HH. Well, how do you get HH? Man, you did substitution, so you're supposed to end up with a Cl here. Okay? So it's going to be this one also because remember, like I told you, over here in chlorination, the hydrogen comes and takes the place of this chlorine, and you're going to be left with HCl over here. Okay, question 19. Okay, ethene C2H4 has the following structural formula. Ethene reacts with hydrogen gas at high temperature and pressure. What's this type? Hydrogenation. What are you doing? You're adding addition. Choose the chemical formula for the product of the hydrogenation of ethene. Hydrogenation of ethene. What is ethene? Ethene is C2H4. You're adding hydrogen, H2. Add H2, you're going to get C2H6. Choose the homologous series of the product of the hydrogenation. So this product, what's the family of it? C2H6. What rule does this obey? Hydrogen, is it double C2? No, but check. Even if it isn't, what's double C2? It's 4. So how do you go from 46 plus 2? That's how you check, okay? Check how much the double of the carbon value is, okay? And see how much more you need to reach the hydrogen, okay? So you need to add 2, so it's going to be 2N plus 2, so that means alkanes. Choose the correct calcification of the product of hydrogenation of ethane. Obviously, this one is saturated. Why is it saturated? Because we know alkanes don't have a carbon double bond, so if there's no carbon double bond, then it's saturated. Ethanol C2H5OH can be produced from ethene under certain conditions. How do you go from ethene C2H4 to ethanol C2H5OH? You're missing 2 hydrogens and 1 oxygen. You're missing 2 hydrogens, 1 oxygen. What's that? Water. Okay, so you're gonna do hydration reaction, right? Okay, you're gonna add water. So what do we need to add? Water. What do they call it? Steam. Why do we say steam? Because under the certain condition, if they gave you the option between water and steam, you choose steam. Why? Because at that condition, 300 degrees Celsius, the high temperature, water will no longer be a liquid. So that's why we say, like in the reaction, you're going to be using steam, not water. Okay. Ethene reacts readily with chlorine, Cl2, at room temperature. Locate the product of the reaction between ethene and chlorine. So ethene, C2H4, and chlorine, Cl2. Like I told you, ethene alkenes don't do substitution. So it's going to do chlorination and bromination. Alkanes also do chlorination and bromination. But what's the difference between alkanes and alkenes, chlorination, bromination? That for alkanes, it's substitution. But for alkenes, it's addition. So alkenes is just going to add the Cl2. So this is how the alkenes look. Okay, we drew this already, by the way. When you come and add the Cl2, this breaks. Okay, so you're going to be left with CCH, okay, over here. And you're going to now add Cl. Okay, perfect. Question 20. Child, it's short. Choose the structure of unsaturated hydrocarbons. Unsaturated, what does that mean? Carbon double chain. Does this have carbon double? No. Does this have carbon double? Yes. Does this have carbon double? No. Does this have carbon double? Yes. Thank you so much for watching, and good luck in your chemistry CA.